November 8, 1942, Richmond Shipyard No. 2, California. Welding supervisor Margaret Thompson stared at a schedule that called for something impossible. Build a complete 441-foot Liberty ship, from keel to launch, in 4 days. Not 4 months. 4 days. Henry Kaiser, the industrialist who'd never built a ship before 1940, had just bet his reputation that American workers could assemble 14 million pounds of steel faster than a German U-boat could sink it. The SS Robert E. Peary's keel would be laid in 6 hours. In 110 hours, it would slide into San Francisco Bay as a fully functional cargo vessel. Traditional shipbuilders said it couldn't be done. Their ships took 250 days. Kaiser's averaged 45 days, already a miracle. But 4 days would prove something more important than speed. It would prove that American industrial democracy could outproduce fascist tyranny by a factor so overwhelming that Germany's defeat became mathematical inevitability. By 1943, Kaiser's 4 Richmond shipyards would complete 3 Liberty ships every single day. 1 ship every 8 hours. 1 ship per shift. That's what Thompson and 90,000 workers at Richmond were about to make routine. The Atlantic Ocean was a graveyard in 1940. German U-boats prowled beneath the surface like wolves, hunting Allied merchant convoys. Karl Dönitz, commander of Germany's submarine fleet, had perfected the Wolfpack tactic. Multiple U-boats coordinating attacks, overwhelming convoy escorts, sinking dozens of ships in single nights. The mathematics were brutal and simple. In June 1940 alone, U-boats sank 550,000 tons of Allied shipping. British shipyards could build maybe 200,000 tons per month, less than half the loss rate. At that trajectory, Britain would run out of merchant shipping by mid-1942. Without merchant ships, no food reached British ports. Without food, Britain starved. Without Britain, Nazi Germany controlled all of Europe. Winston Churchill later wrote, "The only thing that ever really frightened me during the war was the U-boat peril. Not the Luftwaffe bombing London, not Rommel in North Africa, not the threat of invasion, the slow strangulation of Britain's supply lines." President Franklin Roosevelt understood the equation with crystal clarity. In December 1940, he delivered his Arsenal of Democracy speech, pledging unlimited support to Britain. But support required ships, thousands of them, ships to carry food, fuel, ammunition, tanks, aircraft, troops, ships to replace losses faster than U-boats could sink them. The U.S. Maritime Commission, led by Admiral Emory Land, calculated the requirement: 200 new cargo ships immediately, with production accelerating to 24 million deadweight tons annually by 1943. That's 2,000 ocean-going cargo ships per year. The entire American shipbuilding industry had produced 71 ships in 1939. Traditional shipyards, Todd, Bath Iron Works, Newport News, said the goal was impossible. They were right. Using traditional methods, traditional shipbuilding meant constructing ships from the keel up, one at a time, by skilled craftsmen who'd apprenticed for 5 to 7 years. Riveters, plate workers, pipe fitters, electricians. Each trade required years of training, and traditional shipyards operated at capacity building naval vessels. Destroyers, cruisers, battleships, aircraft carriers for the expanding U.S. Navy. There was no spare capacity for merchant ships. Admiral Land needed new shipyards, built fast, operated by workers who didn't yet exist. Using techniques that hadn't been proven, he needed someone willing to try something impossible. He found Henry Kaiser. Henry John Kaiser was 58 years old in 1940. Born in upstate New York, 8th grade education, self-made industrialist. He'd started in road paving, building highways across the American West in the 1920s. In 1931, he'd been part of 6 companies, the consortium that built Hoover Dam. then Bonneville Dam on the Columbia River, then Grand Coulee Dam, the largest concrete structure in the world. Kaiser understood massive projects requiring coordination of thousands of workers, millions of tons of material, tight deadlines, harsh conditions. He understood that impossible just meant nobody had figured out how yet. When the Maritime Commission approached him in late 1940 about building 30 cargo ships for Britain, Kaiser had never built a ship. He knew nothing about naval architecture, nothing about marine engineering, nothing about traditional shipbuilding. Traditional shipbuilders considered this disqualifying. Kaiser considered it an advantage. He wasn't constrained by how we've always done it. He could look at shipbuilding with fresh eyes and ask, why does it take 6 months to build a ship? The answer, he discovered, was tradition. Ships were built the way they'd been built since the 1800s. Keel laid first, frames attached to keel, plates riveted to frames, one at a time, decks built last, machinery installed through deck openings after the hull was complete, sequential construction, each step waiting for the previous step to finish. One crew of skilled workers doing everything. Kaiser had seen this before at Hoover Dam. The initial plan called for building the dam from the bottom up, one massive pour of concrete at a time, each pour requiring months to cure before the next. Total construction time, 12 years. Kaiser had revolutionized it. Instead of one massive dam, build it as interlocking blocks, 230 vertical columns poured simultaneously. Cool each column with embedded refrigeration pipes. Reduce curing time from months to days. Construction time, 4 years instead of 12. Same principle could apply to ships. Don't build sequentially, build simultaneously, multiple sections at once. Assemble them like building blocks. But this required welding instead of rivets. Welding was controversial in 1940. The American shipbuilding establishment considered it dangerous, unreliable, unsuitable for ocean-going vessels. Rivets had built ships for a century, proven, reliable, understood. Each rivet was a discrete connection point. If one failed, the others held. Welding created continuous joints. If a weld failed, the crack could propagate across the entire hull. The British had tried welding on merchant ships in the 1920s. Several had cracked in cold North Atlantic water. The Royal Navy banned welding for critical hull structures. But Kaiser had seen welding work. The Ford Motor Company plant in Richmond, right next to where Kaiser would build his shipyard, used welding extensively in automobile manufacturing. Ford's engineers had perfected electric arc welding, creating joints stronger than the surrounding metal. Kaiser visited Ford's plant, studied their techniques, hired their engineers. He concluded that the British failures weren't due to welding itself. They were due to poor welding procedures, inadequate inspection, insufficient understanding of metallurgy. Modern welding, properly executed, was superior to riveting. Faster, a welder could join plates in minutes versus hours for riveting. Lighter, welded hulls weighed 300 tons less than riveted hulls, no rivet weight. Stronger, properly executed welds created joints as strong as the base metal. And crucially, welding could be learned in weeks, not years. This was the key insight. Traditional riveting required 4-person teams. A heater warming rivets in a forge, a catcher catching red-hot rivets in a bucket, a bucker holding a heavy dolly against the rivet head, a riveter with a pneumatic hammer driving the rivet. Each position required months of training. The riveter position required years of apprenticeship. Welding required one person with a torch, following procedures that could be taught in 21 days. This meant Kaiser could hire anyone and train them quickly. But it also meant Kaiser had to develop training programs, welding standards, inspection procedures that didn't exist. He hired the best welding engineers in America, developed training courses at Richmond, 3 weeks of instruction, 8 hours per day. First week, theory of welding, metallurgy basics, safety procedures. Second week, practice on flat plates, vertical plates, overhead welding. Third week, practice on actual ship sections under supervision. Then graduates went to work on real ships. The establishment predicted disaster. They were wrong. Richmond, California in 1940 was a small city of 23,000 people on the eastern shore of San Francisco Bay. It had a deep-water port, rail access via Southern Pacific, and proximity to San Francisco. The Ford Motor Company had built an assembly plant there in 1930, producing Model A cars. By 1940, the plant had switched to producing military trucks and jeeps for the expanding defense program. Kaiser saw opportunity. The mudflats south of Ford's plant could be dredged and filled. The location had everything needed for shipbuilding: deep water, rail access, proximity to steel suppliers, available land for expansion, and it was 3,000 miles from the war. German bombers couldn't reach California. U-boats couldn't shell the shipyards. Unlike British shipyards, which operated under constant threat of air attack, Richmond could build ships in peace. On December 20, 1940, Kaiser signed the contract to build 30 British cargo ships. 10 hours later, literally 10 hours, construction crews were on site, beginning work. This astonished the Maritime Commission. Most contractors took months to begin work after contract signature. Legal reviews, financing arrangements, site surveys, engineering studies. Kaiser had crews in the mud the same day. By December 21st, pile drivers were hammering pilings 60 feet into bedrock, creating foundations for shipways. By January, 7 shipways were taking shape. Massive steel frameworks 500 feet long sloped toward the water. Ships would be assembled on these ways, then launched by sliding down rails into the bay. Simultaneously, warehouses were being erected, 80 acres of covered space for prefabricating ship sections. Machine shops, welding shops, storage yards, administration buildings. A complete industrial complex rising from mudflats in weeks. Traditional shipyards took years to build. Kaiser built Richmond Yard 1 in 78 days. On April 14, 1941, 78 days after contract signature, the first keel was laid for the SS Ocean Vanguard, a British cargo ship. Traditional shipbuilders stopped laughing. They started worrying. Because Kaiser wasn't building ships the traditional way, he was manufacturing them. The technique was called modular construction. Here's how it worked in detail. A Liberty ship contained approximately 250,000 individual parts: steel plates, frames, beams, brackets, pipes, valves, cables, machinery. Total weight, 14 million pounds. Traditional shipbuilding assembled those parts sequentially on the ways. Start with keel, add frames, attach plates one at a time, build upward. One main crew working one section, moving from bow to stern, bottom to top. Construction time, 200–300 days. Kaiser split the ship into 170 prefabricated sections, built simultaneously in warehouses. Bottom sections, 5 units comprising the ship's floor from bow to stern. Each unit, keel section, floor plates, frames, longitudinal beams, inner bottom plating, built in warehouses as complete assemblies, then moved to the ways. Side sections, port and side shell plating, 40 feet long, 30 feet high, complete with frames, stringers, portholes. Built vertically in warehouses, then tilted and moved to the ways. Bulkhead sections, the vertical walls dividing the ship into compartments. Each bulkhead, steel plates, frames, doors, ventilation trunks, electrical penetrations, all welded together as one unit. Built in warehouses, then craned into position between hull sections. Deck sections, 40 feet by 60 feet, including deck plating, hatch combings, cargo gear foundations, ventilation openings. Built in warehouses, lowered onto the hull in one piece. Superstructure, the entire midships house, 4 decks of crew quarters, galley, mess hall, hospital, bridge, radio room, captain's quarters. Built as a complete unit, 60 feet long, 40 feet wide, 30 feet tall, weighing 120 tons, every door installed, every window glazed, every bunk welded in place, every electrical fixture mounted. Then the entire structure craned onto the deck in one lift. Engine room, boilers, main engine, auxiliary generators, pumps, piping, all installed in a prefabricated section, then lifted into the hull as one unit. This was revolutionary. Traditional shipbuilding installed machinery last, after the hull was complete, lowering boilers and engines through deck openings. Time-consuming, difficult, requiring precise measurements. Kaiser installed machinery first, building the hull around it. Faster, easier, no measurement issues because the sections were prefabricated to exact specifications. The precision required was extraordinary. If bottom section 3 was 1/8 inch too short, it wouldn't mate with bottom section 4. If a bulkhead was 1.4 inch out of square, it wouldn't fit between hull sections. If the superstructure was 1.2 inch off-center, deck penetrations wouldn't align with piping below. Kaiser solved this with jigs, metal frameworks that held components in exact position during welding. Every warehouse had jigs for every section type. Bottom section jig, a massive steel framework, upside-down ship shape, holding keel and frames in perfect position while welders joined them. Bulkhead jig, vertical framework ensuring bulkheads were perfectly square, perfectly flat. Superstructure jig, multi-level framework allowing workers to build 4-deck structures with millimeter precision. The jigs were expensive, tens of thousands of dollars each. But once built, they could be used thousands of times. Build one jig for bottom section 1, use it for 500 ships. The cost per ship dropped to dollars, and the precision was perfect every time. By early 1942, Richmond had 4 shipyards operating. Yard 1, the original, 7 ways, building British Ocean-class ships and later Liberty ships. Yard 2, opened April 1941, 8 ways, specializing in Liberty ships, would set all speed records. Yard 3, opened January 1942, 6 ways, building Victory ships, larger, faster successors to Liberty ships. Yard 4, opened April 1942, 8 ways, building landing ship tanks, LSTs, for amphibious operations. 29 ways total, each capable of building 1 ship simultaneously. If each way completed 1 ship per month, that's 29 ships per month from Richmond alone. But Kaiser's goal was faster, 1 ship per way every 3 weeks. That's 38 ships per month, 1 ship every 19 hours. To achieve this required a workforce unlike anything American industry had ever seen. In 1940, Richmond's population was 23,000. By 1943, Richmond's population exceeded 100,000. 77,000 people moved to Richmond in 3 years. They came from everywhere. Dust Bowl refugees from Oklahoma and Texas. Farmland turned to wasteland by drought and depression. Southern textile workers from mills paying $0.25 per hour. Midwestern factory workers from shuttered plants. Housewives from California suburbs seeking war work. African Americans from Louisiana, Arkansas, Mississippi. Sharecroppers earning $3 per week, hearing about Richmond jobs paying $48 per week. They came because Kaiser advertised nationwide. Newspaper ads. Help build ships, $1.20 hour, housing available, free training. Radio announcements. Recruiting offices in major cities. Kaiser even sent recruiters to southern states, hiring entire families, and they came despite knowing Richmond had nowhere for them to live. The housing crisis was catastrophic, biblical in scale. 90,000 workers needed housing. Richmond had maybe 5,000 available units. Apartments, rooms, houses for rent. The overflow was devastating. People slept in cars parked in muddy lots, entire families in Ford sedans. They slept in trailers, 15,000 trailers crowded into trailer courts, with minimal sanitation, no running water, overflowing sewage. They slept in tents pitched in fields. They slept in converted chicken coops, barns, sheds, garages. One landlord reportedly subdivided a 2-bedroom house into 12 rooms by hanging sheets, $10 per week per room. Another allegedly rented closet space, workers sleeping standing up, $10 per week. Photographs from 1942 show families living in cars, cooking on blowtorches, children doing homework in back seats. One photo shows a woman washing dishes in a bucket outside a converted bus labeled Home Sweet Home. The caption reads, "This shipyard worker's wife wants a kitchen." The federal government responded with emergency housing projects. The Maritime Commission funded 25,000 housing units in 18 months. Entire neighborhoods built from scratch. But even that wasn't enough for 90,000 workers. Kaiser built more. He constructed company housing, simple wooden structures, 4 units per building, minimal but functional. Rent, $50 per month for a 2-bedroom unit, deducted from paychecks, not luxury but better than cars and tents. He also pioneered something revolutionary, 24-hour childcare. The Kaiser Child Service Centers opened in 1943, funded by the Maritime Commission. 2 centers, one at Yard 1, one at Yard 2. Open 24 hours daily, 7 days weekly. Capacity, 1,500 children total. Working mothers could drop children off at any hour. 7 a.m. for day shift, 3 p.m. for evening shift, 11 p.m. for night shift. The centers provided everything: meals, medical care, education, even mending children's clothes. Cost, $50 per week per child, deducted from paychecks. For working mothers, this was transformative. Before the centers, many women couldn't work because childcare didn't exist. Now they could work any shift, knowing their children were safe, fed, supervised. This wasn't charity. Kaiser understood that worker productivity required solving worker problems. Exhausted parents worried about children don't weld well. Well-rested parents with children in good care produce better work. The same logic applied to healthcare. Kaiser revolutionized industrial healthcare. Traditional industrial medicine in 1940 treated workplace injuries, set broken bones, stitch cuts, treat burns. Nothing else. If workers got sick outside work, that was their problem. Kaiser had pioneered a different model at Grand Coulee Dam. He'd hired Dr. Sidney Garfield, a young surgeon with radical ideas. Garfield proposed prepaid healthcare. Workers paid a small amount from each paycheck, received complete medical care in return, not just injury treatment, preventive care, dental, vision, surgery if needed. At Grand Coulee, the program worked brilliantly. Workers stayed healthier, missed fewer days, produced more. Kaiser brought Garfield to Richmond in 1942. They built clinics at each shipyard, small buildings with exam rooms, basic equipment, doctors on staff. They built a hospital, Richmond Field Hospital, opened August 1942. Initially 10 beds, expanded to 50 beds by 1943. Workers paid $0.50 per week from paychecks, $26 per year. Families could join for $1.50 per week total, $78 per year. In return, complete health care, no additional charges, no bills, no forms. See a doctor, get treated, go back to work. Revolutionary. Traditional healthcare in 1940 meant paying doctors directly. $5 for an office visit, $50 for surgery, hundreds for hospitalization. Many workers couldn't afford it, so they didn't seek care until emergencies. Kaiser's prepaid system meant workers sought care early, preventing small problems from becoming big problems. Healthier workers, lower absenteeism, higher productivity. After the war, Kaiser spun off the healthcare system as a separate entity. Kaiser Permanente, now one of the largest HMOs in America, serving 12 million members. Born in Richmond's shipyards. Built on the principle that healthy workers are productive workers. But the real revolution was on the ways. By November 1942, Richmond's techniques had been refined through 18 months of practice. The first Liberty ship, laid down in May 1941, had taken 197 days from keel to launch. By January 1942, construction time had dropped to 105 days. By June 1942, it had dropped to 56 days. By September 1942, Richmond Yard 2 averaged 42 days from keel to launch. This was already miraculous. Traditional shipyards needed 250 days. But Kaiser wanted faster. The Oregon Shipbuilding Corporation, another Kaiser yard in Portland, had built the SS Joseph N. Teal in 10 days in September 1942. A publicity stunt, but it demonstrated what was possible. A reporter asked Kaiser if Richmond could beat it. Kaiser, never one to back down from a challenge, said, "We can do it in 5 days." The bet was on. And on November 8, 1942, Richmond Yard 2 would attempt the impossible. The SS Robert E. Peary would be built to prove a point. Not that ships could routinely be built in 4 days. They couldn't. The bottleneck was prefabrication, not assembly. Richmond's warehouses could produce sections for maybe 2 ships per week at maximum output. Building one ship in 4 days required stockpiling sections for weeks in advance. Not sustainable for regular production. But it would prove that assembly time could be compressed to hours with perfect coordination. It would prove that welded ships could be built with extreme speed without compromising quality. It would prove that American workers, many of them trained for only months, could match the precision of workers with years of experience. And it would prove to Germany that American industrial capacity was unstoppable. For 2 weeks before November 8th, Richmond Yard 2 prepared. Every section for the Robert E. Peary was prefabricated to exact specifications. Bottom sections, side sections, bulkheads, decks, superstructure, everything. Each section inspected, X-rayed, measured, certified. Then staged near the ways in exact sequence for assembly. Crane operators practiced lifting procedures. Welders practiced on identical sections, timing themselves, perfecting technique. Foremen created minute-by-minute schedules. 0800, lift bottom section 1. 08115, position and weld. 0830, lift inner bottom section. 0845, position and weld. 0900, lift boilers. Every operation timed, every crew coordinated. The entire shipyard became a choreographed performance. On November 7th, the ways were cleared, foundation blocks positioned, welding cables laid out, gas bottles staged, cranes positioned. Margaret Thompson gathered her 50-person welding crew. "Tomorrow we make history," she told them. 4 days, the world is watching, don't screw up. They didn't. November 8th, 1942, 8 a.m. Richmond Shipyard. Number 2, Day 1 begins. The 100-ton bottom shell unit, keel, floor plates, frames welded as one piece, rose from the fabrication yard. Crane cables went taut, groaned under the load. The section swung over way 2, lowered toward foundation blocks. Workers guided it with ropes, positioned it exactly, signaled the crane operator. The section settled onto blocks with a metallic thud. Welders swarmed it immediately, 20 people surrounding the section. Arc welders struck, sparks showering, the hiss and crackle of metal joining metal. Within 15 minutes, the bottom shell was welded to foundation blocks. At 8:15 a.m., the inner bottom unit came in, 150 tons, including structural supports for boilers and main engine. Cranes positioned it atop the bottom shell. Welders connected them, joining along seams with continuous beads. By 9 a.m., the boilers arrived, two massive units, 20 feet tall, 12 feet diameter, 30 tons each. In traditional shipbuilding, boilers were installed last, lowered through deck openings after the hull was complete. Kaiser installed them first. Cranes lifted the boilers, lowered them into the inner bottom unit, positioned them on pre-installed mounts. Welders secured them. By 10 a.m., transverse bulkheads were arriving, the vertical walls dividing the ship into 5 cargo holds and engine room. Each bulkhead, 40 feet wide, 30 feet tall, built in warehouses as complete units. Cranes lifted them, positioned them perpendicular to the keel, lowered them into place. Welders connected them to bottom sections and to each other. By noon, 4 hours into construction, the ship had shape: keel, bottom structure, boilers, bulkheads. You could walk through and see cargo holds taking form. At noon, the official keel-laying ceremony began. Eleanor Roosevelt arrived, toured the yard, met workers. She posed for photographs, welded a symbolic bead onto the keel, declared the ship begun. Then she stepped back and watched construction continue at speeds that astonished her. By 6 p.m., end of first shift, the bottom of the ship was complete. All bottom sections, all bulkheads, shaft tunnel, fantail structure, inner structure for upper decks. The ship was 30% complete. First shift went home. Second shift arrived, picked up welding torches, continued. Day 2, November 9th. By dawn, upper deck sections were arriving. These weren't small pieces. Each deck section, 40 feet long, 60 feet wide, complete with deck plating, hatch coamings, ventilation trunks, cargo gear foundations. Weight, 40 tons per section. Cranes lifted them, swung them over the hull, lowered them onto bulkheads. Welders connected them, thousands of feet of weld bead, joining deck to bulkheads, deck sections to each other. By noon, the main deck was complete, one continuous surface from bow to stern. Workers could walk the length of the ship, 441 feet, on solid steel decking. Also installed, forepeak and aft peak, watertight compartments at bow and stern, providing flotation. By evening, the ship had its hull. Complete from keel to main deck, bow to stern, it looked like a ship now. Recognizable shape, cargo holds visible, superstructure mounting points ready. Day 3, November 10th. Superstructure day, the most dramatic. At 8 a.m., the midships house arrived. This structure had taken 3 weeks to build in a warehouse. 4 decks, crew quarters on the lower 2 decks, galley and mess hall on the 3rd deck, bridge and navigation on the 4th. Complete with doors, windows, bunks, toilets, sinks, electrical wiring, lighting fixtures. It looked like an apartment building, 60 feet long, 40 feet wide, 30 feet tall. Weight, 120 tons. It took 2 cranes working in tandem to lift it. Cables attached to lifting points, both cranes synchronized. The structure rose from the fabrication yard, swung over the ship. Workers on deck guided it with ropes. It lowered onto pre-positioned mounting points. Welders connected it. A marathon 6-hour welding session joining the superstructure to the deck, with welds that would hold through Atlantic storms. Also installed during day 3. 3 masts, hollow steel tubes, 80 feet tall, step through deck into keel structure. Cargo booms, 28 booms total, using them to lift cargo in and out of holds. Davits for lifeboats, 4 boats, 24 feet long, capacity 25 persons each. Smokestack, 40 feet tall, connected to boiler exhaust. By evening, the SS Robert E. Peary looked like a complete ship. Hull, deck, superstructure, masts, boats. It needed only finishing. Day 4, November 11th. Finishing day. The marathon. Electrical work, miles of cable running through the ship, connecting generators to lights, pumps, navigation equipment, radios, galley equipment. Electricians worked in teams, pulling cable through conduits, connecting terminals, testing circuits. Plumbing work, fresh water system piped from tanks to galley, crew quarters, engine room. Saltwater cooling system piped from sea chests to engine, pumps, condensers. Sewage system piped from toilets to holding tanks. Pipe fitters worked alongside electricians, threading pipes through bulkheads, welding connections, pressure testing systems. Painting, hull below waterline painted with anti-fouling paint. Copper-based paint, preventing barnacles and marine growth. Superstructure painted haze grey, Navy standard, though this was a merchant ship. Deck painted with non-skid coating. Armament installation, forward gun platform for 3-inch deck gun, aft platform for 5-inch stern gun, 8 20mm anti-aircraft gun mounts. The guns themselves would be installed later by Navy personnel, but mounting points had to be ready. Final welding inspection, every critical weld X-rayed, looking for voids or cracks. Thousands of welds, spot-checked for quality. Any defects, grind out, re-weld, re-inspect. Final systems testing, start boilers, bring steam up, test engine, test generators, test pumps, test steering gear. Everything had to work. At 3 p.m., 4 days, 7 hours after keel laying, the SS Robert E. Peary was complete. Every system tested and operational, every inspection passed, ready for launch. At 3:27 p.m. on November 12, 1942, the SS Robert E. Peary was christened. 10,000 workers crowded the shoreline. Newsreel cameras on platforms, filming for national distribution. Reporters from every major newspaper, New York Times, Washington Post, Los Angeles Times, Chicago Tribune. Radio correspondents broadcasting live. And Eleanor Roosevelt, representing the president, standing at the bow with a champagne bottle. Margaret Thompson stood with her welding crew, exhausted beyond description. 4 days without real sleep, rotating through shifts, grabbing naps in the break room. Her hands trembled from welding torch vibration. Her eyes burned from arc flash glare, despite her welding hood. Her back ached from bending over welds for hours. But she'd done it. They'd all done it. 250,000 parts, 14 million pounds of steel, 50 miles of weld bead, assembled in 110 hours. Eleanor Roosevelt raised the champagne bottle. I christen thee SS Robert E. Peary. May God bless this ship and all who sail in her. She swung the bottle. It shattered against the bow, champagne foaming down the hull. Workers knocked away the blocks holding the ship. The ship shuddered, paused, then began sliding down the ways. Gravity pulled 10,500 tons of steel toward San Francisco Bay at accelerating speed. The launch lasted 12 seconds. The splash was spectacular, water erupting 50 feet high, waves radiating outward. The ship rocked, settled, floated. Perfectly. The crowd erupted in cheers that echoed across Richmond. Workers hugged, cried, threw hard hats and welding hoods into the air. Margaret Thompson felt tears streaming down her face and didn't bother wiping them away. They'd done the impossible. 4 days, 15 hours, 29 minutes. A complete liberty ship, built by American workers, proving that democracy could outproduce fascism, proving that free labor could outwork slave labor, proving that American ingenuity was unstoppable. The SS Robert E. Peary served honorably for 3 years. It carried cargo across the Atlantic, ammunition, tanks, food food, fuel. It carried cargo across the Pacific, supplies for island bases, equipment for the Philippines. It sailed through storms, dodged U-boats, survived near misses from bombs. It never broke, never cracked, never had a structural failure. The welded hull, which critics predicted would fail, held through everything the ocean could throw at it. In 1945, after the war ended, the Robert E. Peary was sold to commercial shipping companies. It carried grain, machinery, consumer goods. It operated for 18 more years. In 1963, it was finally scrapped, 21 years after that 4-day construction. So much for throwaway ships. The publicity stunt worked beyond Kaiser's wildest expectations. Newsreels showed the construction, the launch, the celebration. Theaters across America showed Americans what their workers could build. More importantly, newsreels reached occupied Europe, shown in neutral countries, smuggled into Germany. Albert Speer, Hitler's armaments minister, later wrote in his memoirs that seeing the Robert E. Peary launch was the moment he realized Germany would lose the war. "We calculated that our entire shipbuilding industry could not match what one American shipyard achieved in 4 days," he wrote. "Our U-boat production was 30 per month at peak. American merchant ship production was 150 per month. We could not sink them fast enough. The mathematics were insurmountable." He was right, but the real miracle wasn't the 4-day ship. The miracle was what happened after. Richmond didn't stop at one publicity stunt. Richmond made speed routine. By January 1943, Richmond Yard 2 averaged 30 days from keel to launch. By June 1943, that dropped to 24 days. By December 1943, Richmond averaged 17 days on the ways. Add prefabrication time, and total construction averaged 42 days from raw steel to finished ship. And Richmond's 4 yards combined were launching 3 ships per day. 1 ship every 8 hours, 1 ship per shift every day. That's not a publicity stunt. That's industrial production at a scale that changed warfare forever. Consider the numbers. From 1941 to 1945, Richmond's 4 yards built 747 ships. Richmond Yard 1, 282 ships, Ocean Class and Liberty ships. Richmond Yard 2, 330 ships, Liberty ships and Victory ships. Richmond Yard 3, 84 ships, Victory ships. Richmond Yard 4, 51 ships, LSTs and frigates. That's 27% of all U.S. Maritime Commission construction during World War II. That's more ships than any other shipyard complex in history. More than Japan's entire wartime production. More than Germany's, more than Britain's. And Richmond was just one of 7 Kaiser shipyards. Add Oregon Shipbuilding Corporation, 455 ships. Add Swan Island Shipyard, 147 ships. Add Vancouver Shipyard, 150 ships. Add 3 smaller Kaiser yards, another 191 ships. Total Kaiser production, 1,490 ships. 27% of all American maritime construction. Built in 2/3 the time at 1/4 the cost of the industry average. The workers who built these ships came from everywhere and nowhere. Margaret Thompson, welding supervisor, former housewife from Fresno, learned to weld in 3 weeks, supervised 50 workers within 6 months, trained 200 women welders during the war. Marie Baker, 62-year-old great-grandmother, former seamstress, became an overhead welder. Known for squeezing into spaces younger workers couldn't reach. Beatrice Harris, 19, from Mississippi, African-American, hired as a laborer, promoted to welder, worked night shift for 2 years, sending money home to family. William Chen, Chinese immigrant, machinist, operated lathes in machine shops, trained 30 apprentices, worked every day from 1942 to 1945 without missing a shift. Joseph Kowalski, 58, Polish immigrant, former coal miner, became a crane operator. Lifted 100-ton sections with millimeter precision. Rosa Martinez, Mexican-American, mother of 4, worked swing shift. Children in Kaiser childcare, became pipefitter, specialized in steam piping. These weren't heroes in the traditional sense. They didn't storm beaches or fly fighters. They punched time cards, welded steel, went home exhausted. But they won the war. Every ship they built carried the tools of victory. Every tank, every truck, every rifle, every bullet, every bandage, every meal, all crossed oceans on ships these workers built. 2 million American soldiers reached Europe on ships built at Richmond. 100 million tons of cargo crossed the Atlantic on Liberty ships. Without those ships, D-Day doesn't happen. Without those ships, Europe stays under Nazi control. Without those ships, the war lasts years longer. The workers at Richmond shortened World War II by months, saved hundreds of thousands of lives, defeated fascism. By welding steel, 8 hours per shift, 3 shifts per day. 1 ship every 8 hours. For 4 years. Today, Richmond's shipyards are gone. The ways were scrapped for steel in 1946. The warehouses demolished. The mudflats returned to nature. But memory remains at the Rosie the Riveter, World War II Homefront National Historical Park. Richmond Shipyard No. 3 is preserved as a National Historic Site. Visitors can walk the ways where ships were built. They can see the whirly cranes. Massive cranes that lifted 100-ton sections still standing, rusted but intact. They can tour the warehouse where sections were prefabricated. They can see photographs covering the walls. Margaret Thompson, welding torch raised, sparks showering. Marie Baker, 62, welding overhead in a cargo hold, face protected by leather hood. African-American workers moving steel plates with determination. Women working alongside men, equals in production. And they can read the statistics on plaques. 747 ships, built in 4 years. 90,000 workers at peak employment. 3 ships launched per day in 1943, 1944. 1 ship every 8 hours for 2 years straight. The most productive shipyard complex in history. Never equaled, before or since. The legacy isn't the 4-day ship, though that's remembered. The legacy isn't Henry Kaiser, though he deserves credit. The legacy is 90,000 ordinary Americans who became extraordinary by doing the impossible daily. Teachers who became welders. Farmers who became crane operators. Housewives who became supervisors. Grandmothers who became shipfitters. They came to Richmond with nothing but determination. They learned skills in weeks that traditionally took years. They worked 8-hour shifts in rain, heat, and darkness. They built ships that won the war. 3 per day, 1 every 8 hours. 747 total, until victory was certain. Until fascism was defeated. Until democracy was preserved. That's the miracle of Richmond, not the speed, the people, the workers. Who proved that American industrial democracy, powered by free labor and ingenuity, could outproduce any tyranny. And did.